Hi everyone. Like we discussed in earlier video about the data acquisition. The next step will be the data processing. In the data processing, the main technique is filtering. That we are going to discuss in today's video. So after data acquisition, the data should be processed. So we have multiple techniques for processing the data processing techniques. One such majority filtering is the technique majority technique. So what is the filtering? Nothing but unstructured data, so that they can be eliminated and which will be structured into a particular manner. So what is the purpose of data filtering? If we see first, the goal of this one is to process and clean the sensor data to remove inaccuracies and redundancies. Redundancies is nothing but multiple times same data will be there. So those type of duplicates can be removed, and a few of the things will be inaccuracy data. So that in accuracy, lack of accuracy, that data can be removed and redundancies can be removed. Then the data will be on an organized manner, which will enhances the data quality, and the volume size also get decreases, which will improve the responsiveness. What are the application areas? So whenever object detection and tracking, and any predictive maintenance in the factories, inventory management or stock management, or the raw material management, any motion control. So what are the, if you see what are the common filtering techniques, is nothing but thresholding is the one of the major technique. Moving average method is the next major technique. Kalman filtering, digital signal processing filters. So these are the major filters which are we are using for removing that redundancies and unwanted inaccurate data. So what will be the benefit? Like I told earlier point, the data of data volume will be reduced. Hence, we can able to produce more accuracy with improved accuracy, and the processing also will be faster if that data volume gets reduced. Edge computing and filtering. So edge computing at the device level itself, it is going to filter the data and process. So then the next technique after filtering is data aggregation process. So the data aggregation is nothing but is a crucial technique which will be after collecting the data and organizing the data. So overall, the data can be aggregated using by retrieving data from multiple sources, that will be cleaned and prepared input data. So that will be found by done by combining and organizing the data. So, what are the data aggregation techniques? If we see temporal aggregation, spatial aggregation, hierarchical aggregation, and model based aggregation. So, if we see temporal aggregation, we are collecting specific data before transmission. Whereas coming to spatial aggregation, multiple sensors located closely to proximity to collection of the environment, there itself it will do that thing. Hierarchical aggregation is aggregated at different network levels, reaching the client server, whereas model based aggregation based upon machine learning algorithms. Where we will use as applications of data aggregation is smart cities, healthcare, wearable devices, healthcare, minute to minute or a particular time duration, the data will be sent to doctor or the caretaker of the patients. So if any redundant data, that will be deleted using data filtering models. The organized data by time basis can be done by data aggregation. So this data aggregation can be done in autonomous robots, industrial automations, but few challenges are there in the data aggregation. Well, we doing this process, it will take sometimes it will take more time, which leads to data latency. So the aggregation can make delays and impact real-time applications like remote monitoring of health of a patient, like that. Data integrity and security. Few times the data will be lost, which is very crucial data. Computational complexity is also increases, and which will increases the time also. Thank you.